It's time for our next cheap electronics kit. I bought this off eBay. It cost me £6.50 plus £2.50 shipping, so £9 delivered, and it is supposed to be a stereo 100 watt per channel audio amplifier. So I will be testing this. As ever, this is not a full review of the finished item. This is just a bit of fun to see if this kit is worth what I paid for it. But I will be carrying out a few tests. We'll test the output power, distortion, that sort of thing. But on the face of it, it looks quite a good kit. This is how it was shipped. It was in a bag, but it was all loose like this. And the board looks quite good. It's not a particularly high quality board. And I do not normally clean boards before I use them, but this one's definitely got something on it. So I will be cleaning this before I use it with a bit of isopropyl alcohol. I'm not quite sure what this is. It's kind of sticky residue that's on here, so I will clean that off before we use it. But other than that, the quality of the board seems quite reasonable, and it has the values written on the silk screen, so that should simplify assembly. I'm not expecting much from the instructions. Let's see what's in the kit. Okay, so there are some printed instructions. Let's have a quick look. Not a lot of use other than the cross-reference table, which we may need. But it does have the schematic. Now, this is very similar to an amplifier I built many years ago, and I built it in a modular form, so each of the channels was essentially one of these. As I say, this is supposed to be 100 watts per channel. I somehow doubt it's going to achieve that. It may just be peak power they're talking about, or it may just be a very optimistic specification. But as I say, we will test that. But the schematic looks fairly interesting. It'd be interesting to see how much distortion we get on this. But looking at what's in the kit, we've got what I assume are the heatsinks. So we'll have a quick look, see what's in here. So that's someone's, not sure if that's some sort of game or a packing list, but these are indeed, if you're interested. No idea what that is. If anyone can read that, then please let me know what it says. Okay, some very low cost aluminium heat sinks, not anodized, so obviously they've been keeping the cost down here, but that's not really that surprising on something that only costs a little over £6. And there is quite a number of components. So the reason I do these kits is to try and encourage people that are getting into electronics to try out these kits, give them a go. They're a very good learning tool and identifying components, assembling things, but they can be a lot of fun to play with as well. And this does seem like a very good kit for the money. There's a lot in it. There are no markings on these devices. There'll be something along the lines of a 2N3055, but there are no markings on any of them, so they could be anything. So I don't think it's been scrubbed off, it just never seemed to have been marked, so the quality doesn't seem too bad. And okay, but the rest of the parts, capacitors, no idea what brand that is. And again, this is the main rectifier. This is meant to be a 100 watt per channel amplifier, and there's no heatsink on this rectifier, so I suspect it's going to struggle a bit to reach that power output level. But the kit overall is fairly good. It's a nice collection of parts. They are reasonable quality parts. The resistors seem to be reasonable quality. You can actually read or see the colour code bars on them, so they're quite good. The quality of the screws that are used also seem quite good. but we'll start to assemble this. So as ever, I'll start with the resistors. Before I do that, I'm going to try and clean this board and see if I can get this sticky gunk off the back. Okay, the board cleaned up reasonably well. Bit alarming that some of the solder mask appear to be coming off with isopropyl alcohol, which is a bit unusual. It shouldn't do that, but it is cleaner now and it's not sticky anymore, so hopefully it will solder okay. But step one is to fit all the resistors. The values are on the board, so I'll get the resistors in place and we'll go from there. Okay, that's all the resistors fitted. The board does take solder extremely nicely, so out of all the kits so far that I've shown, this is by far the best board to solder, and it does make it a far more pleasurable experience when you don't have to fight with the board to get the solder to stick to it. So that's good. It's nice to have a decent board. So we'll go on and we'll fit the capacitors, or at least all the small ones, and go on from there. I'll also fit the diodes as well, and we'll see what comes after that. Okay, that's the smaller capacitors fitted. Again, they all went in nicely, none were missing, all the right values. So the next thing I'm going to do is fit the small transistors, and I'm doing those before the big capacitors simply because once you fit the big tool components, it makes the board more difficult to handle when you're trying to solder. So I'll get the transistors fitted and we'll go from there. I've fitted all the smaller transistors, and the next thing I'll put on the board are the connectors. So there's just a handful of connectors, and once we've got that done, I'll fit the bridge rectifier and the larger capacitors, and we can then look at fitting the power transistors. Okay, that's the connectors fitted, just 4 of those. So I'll now fit the large smoothing capacitors and the LED and the bridge rectifier. Okay, so that's all the components fitted apart from the power transistors, so I'll get those fitted next. It's all gone together very nicely, quite a fun board to assemble. It solders nicely and all the parts were correct. They all fitted into the board extremely well, and it's quite a fun kit to assemble so far. Single-sided board of course, and they managed to get away with just a single jumper, so that's quite good. I'll just use one of the leads off the electrolytic capacitors for the jumper, and what I'll do now is get the power devices bolted in place. I'm not going to bother with any conductive paste at this point, any heatsink paste, and I'm not going to put any insulators on here, so we will need to be aware of that the heatsinks will effectively have voltage differential between them, so we need to make sure we don't short those out. But you could fit insulation if you wanted to these, and also heatsink compound if you really wanted to use this in anger, but I'm not going to really use it for much, I shouldn't think, so if ever I need to I can always come back, pop the transistors out and make a better job of fitting them, but for now I'm just going to bolt them in place and we'll see if the board actually works. Okay, that's the kit fully assembled, and it is quite a pleasing kit to assemble. Got quite a bit of weight to it when it's done as well, and it looks very nice, and for just £6.50 it's quite incredible that they can supply even just the parts, let alone the board and heatsinks and everything else. So what we're going to do now is power this up. It'd be interesting to see how well it performs. We'll check the power output and distortion, that sort of thing. It's not going to be a full review, but we'll see initially if it works at all. So stereo board of course, so we've got a pair of output devices for each of the 2 channels. It's got a AC input. Now we could, if we want to, what we'll probably do is just feed that with a plus or minus DC supplies. It'll just make life a lot easier, and I can just use the bench supply for that, but you could hook it up to a transformer if you wanted to. It says 12 to 18 volts, so we'll start off with 18 volts and go from there. And the input, I'm assuming, is just left and right. I'm not going to play music through this. I'll probably end up with a copyright strike on YouTube. But what I will do is hook it up to a signal generator and see how well it performs. Okay, I've got the board hooked up to my 01 bench supply. I've got the supply set to give us plus or minus 9 volts. I've got the input hooked up to a signal generator. Currently it's set to 1 kilohertz, 10 millivolts peak to peak. And looking at the schematic, it looks like it should work with fairly low level inputs. So we'll start with 10 millivolts, see if we get anything. We'll keep an eye on the current drawn. Because we've got a balanced supply here, then we should get fairly low current until we start feeding a signal in. Got a speaker hooked to the output. It's only a 10 watt speaker, but it should certainly let us listen to the sound if anything comes out of the amplifier. I've only got one channel hooked up. They're identical, so I'll just test one channel for now and we'll see what this does. So I'll power up the supply. Okay, got a bit of humming coming from the speaker, and we're drawing 11 milliamps and 6 milliamps from the two rails. I'm going to turn on the signal generator, and we are getting some sound. I'll try adjusting the frequency. Okay, and that's with just 10 millivolts. And the supply does seem to be fairly symmetrical. So I'm going to try turning the input signal down a bit. It's currently plus or minus 10 millivolts peak to peak. Okay, we're down at 4 millivolts. So obviously very sensitive input. We'll try turning this up and see if we get an increase in volume. Okay, so actually getting quite loud. I don't know how well that's coming across on the microphone, probably very annoying for you, but we're definitely getting some sound. Now obviously there's only so much testing I can do like this. It's very kind of arbitrary, and it's just listening to amplifiers, at least for me, I'm getting old, my hearing's not as good as it should be, so it's not going to tell me a great deal. So what I'm going to do is start looking at distortion and power output. I'm not going to do it using an actual speaker. I'm going to put a dummy load on this, and it doesn't really specify, as far as I can tell, exactly what the output is supposed to be. It doesn't normally, with an amplifier for a given power output rating, you'll get an impedance matching requirement. I can't find anything on here that really indicates what it's supposed to be, whether it's supposed to be 8 ohms or 4 ohms, etc. So I'm going to go with 4 ohms, 100 watt amplifier. Chances are it should be able to handle 4 ohms fairly easily. So I'm going to put a 4 ohm dummy load on this, and we'll hook it up to a meter to test the distortion. I'm actually going to use my Keithley meter for this because it has got a built-in total harmonic distortion function. It's extremely useful for this sort of thing. It's also very precise, so we can use that to test for the distortion. Also the output from the signal generators that I have, the distortion will still be too high for what we want, so again I will use the output from the Keithley 2015 for that. Very low noise sine wave output that's adjustable. So I'll get this set up and we'll see what level of distortion we're getting from this with various power levels. Okay, the setup I have here is I've got the output of the board connected to a 500 watt 4 ohm dummy load. I've got the scope set to monitor the input and output of the board. So the yellow trace is the input to the board and the purple trace is the output. I'm using the Keithley 2015 set to measure total harmonic distortion, and I'm using the source output from the Keithley as our signal source. It has a very low distortion level. So we'll start off by measuring the distortion level of the Keithley. So I'll connect the input to the Keithley to the input to the amplifier. So that's the output, the source output from the Keithley. And we can see on the scope the input signal, and it's actually set to 1 kilohertz at 10 millivolts. So very low level input signal, and we'll see how much power output the amplifier can provide. I've got the thermal camera on standby, but with such reflective heat sinks and devices, I'll be relying more on the sniff test. If it starts smelling hot, then I'll turn the amplifier off. I've got the input voltage set to plus or minus 30 volts. It may seem quite high. The specification is 12 to 18 volts, but remember this is AC input, and because we are feeding DC in, and also we've got a voltage drop across the bridge rectifier, then I'm effectively using what would be the rectified and smoothed DC levels, but normally you'd feed this or could feed it from a transformer. So I've got this set to plus or minus 30 volts. This will give it the best possible chance of reaching the 100 watt output. Now this is not really the correct way to measure total harmonic distortion. This is just for a bit of fun, taking some comparative tests, and what we'll be looking at here is just one of the two channels to give the amplifier the best possible chance of giving us a good output. As you can see, we're starting off with very low distortion, down around 0.01%. So we'll now move that through to the output of the amplifier, and we'll turn the supply on. So remember, we've got 10 millivolts peak to peak at 1 kilohertz set from the Keithley. So we'll turn the supplies on. I've got the current limits on both plus and minus rails set to 3 amps. And we can see we are getting a reasonable output signal. Distortion is also still very low, so it's 0.01%, so still very low distortion we're getting. But at the moment we're only outputting about 1 watt from the amplifier. Now the output power is specified at 100 watts, but it's quite difficult sometimes to determine actual output power for an audio amplifier. I assume they're talking about total music output, and that's spread across different frequencies. What we'll probably find is that the amplifier will give a lot of power at low frequency, and that will diminish at higher frequencies, but that's not necessarily a big issue. If you're driving an audio system, then you tend not to put out, comparatively speaking, a lot of power at the higher frequencies. Most of the power is going to come out at the low frequencies. So we're at 1 kilohertz, and that's kind of a nominal value for frequency, so I'm not expecting to get more than a few watts at this frequency. So we'll now start increasing the input level and see how much power we can get before we see clipping on the output. I'm going to go up to 50 millivolts. And still no sign of clipping. And the distortion is still very low at 0.03%. It has risen a bit, but it's still fairly reasonable. And we're drawing about 40 milliamps from each of the two supply rails. So we'll increase the input still further, and and we'll go up to 100 millivolts. Okay, we're now outputting about 3 watts and the distortion has gone up to 0.12%. So we're still not seeing clipping on the output, so we can go up still further. So I would say here that I've got the Keithley set up to only go up to the second harmonic, so as we start getting clipping, the distortion will not rise quite as rapidly as, or at least the indicated distortion will not rise quite as rapidly as you might expect based on what we see on the scope. But that's just because of the way I've got the Keithley set up. I'm really looking for distortion of the sine wave. Okay, so that's 150 millivolts, and we are now seeing clipping of the output. So we've now reached the limit. This is as much power as we can put out at this frequency with this amplifier into a 4 ohm load. And we're outputting about 3.5 watts at 1 kilohertz. Might not sound like a great deal for a 100 watt amplifier, but most of the power you want from an audio amplifier and that you specify and design for is at the lower bass frequencies. So what we'll do now is we'll go down to 400 hertz and see how much power that gives us. I'm going to just quickly reduce the input levels so we've got rid of the clipping, and our distortion is about 0.19%, and you can see the clipping is gone. I've got it set to 140 millivolts peak. So we'll now reduce to 400 hertz. So distortion has dropped a little bit. Power output has indeed gone up quite significantly. We're now putting out about 7 watts and quite reasonable distortion. So we'll go down. In fact, what I'll try and do is increasing the input and just make sure it is clipping due to overdriving and not something else. So yeah, you can see the clipping has come back and it's almost identical to what we had before, and the distortion has risen accordingly. So we'll go back down to 140 millivolts. Distortion's gone down and the clipping has disappeared as we would expect. Okay, so next thing we'll do is go down in frequency. So currently we're at 400 hertz. We'll go into 200 and see. In fact, I'll go into 300. I'll go down in 100 hertz steps here because it will, I suspect, ramp up quite quickly. Okay, so still no clipping. The distortion is still about the same, around 0.1%, and we're up around 9 watts, 9.5 watts output power. So we'll come down still further in frequency. We'll come down to 200 hertz. So you can see the distortion has actually gone down a little bit, and this is not that surprising. It's an amplifier like this is going to perform much better at lower frequencies, and it's now putting out about 15 watts, which is not too bad. So remember, the 100 watts will be spread across the entire audio spectrum that the amplifier can produce, which is why it's called total music power output, which is what I suspect the 100 watts is deemed to be putting out. Okay, so we'll go down again in frequency. I'm going to go down to 150 hertz. Okay, this distortion is still 0.09%. We're now outputting about 18 watts. Just do a touch test on these, and they're still fairly cool. They're starting to heat up, but not alarmingly yet. There's no smoke rising from the board, so we can keep going. Let's have a quick look through the thermal camera. You can kind of probably see they're starting to get hot. We won't get any sensible readings with the thermal camera unless we put some sort of dark pad on the devices, because they're so reflective. We're kind of looking at, if you like, a reflection of heat. So we're probably looking at the temperature, something that's kind of up there. Okay, so we'll go down in frequency yet again. So we'll go down to 120 hertz. Output power is now up around 25 watts. distortion is still about 0.1%, so again quite reasonable. We'll go down to 100 Hz. Okay, distortion is still about 0.1%. Output power is now up around 30 watts, 35 watts, so quite good output power. And although 35 watts is still way short of the quoted 100 watts, as I said, remember that 100 watts is spread across the entire spectrum, and we're just looking at one frequency here. So finally we'll go down to 50 Hz, which is kind of as low as most bass speakers other than the very expensive ones will go, and we'll see how much power that will give us. At the moment we're drawing about 600 milliamps from each of the two power supply rails. Okay, so now we'll set the frequency to 50 Hz. I expect to see a very marked step in output power, so I may have to quickly turn the amplifier off to stop it destroying itself. Okay, and the output power is now about 70 watts, which is quite reasonable, and the distortion has gone up to 0.4%, so it has risen quite significantly. We'll have a look at the output devices, see what they're doing, and what they're doing is getting very hot. So I'm going to now change the frequency. We'll go back up 1 kilohertz. So we're back up at 1 kilohertz. Power's gone back down to what it was previously at 1 kilohertz, but now we'll start going up in frequency, and we'll go up to 3 kilohertz. So distortion has gone up, power has gone down. We're now putting out about 1.5 watts, so we'll go up still further. We'll go up to 10 kilohertz. Okay, distortion is now up around 25%, and you can see on the scope this amplifier just cannot handle this frequency. So it would be an interesting exercise, and again, one of the reasons I find kits like this very useful is if you're learning electronics, is try and modify this circuit to work at high frequencies. Now 10 kilohertz is not particularly high for an audio amplifier. It is, if it's a PA amplifier, then 3 kilohertz is probably high enough, but certainly it's clear this amplifier is of no use whatsoever at 10 kilohertz. But at 3 kilohertz, if we go back down to 3, we can see that we're kind of on the limit of distortion. It's just starting to create severe distortion issues. So I'd say this probably is a 100 watt amplifier. It's not going to give you a continuous 100 watts out at 50 Hertz or any frequency really. It would rapidly overheat, but certainly in terms of total peak music power, I think it's probably safe to say that this will provide 100 watts into a 4 ohm load. So quite interesting. There's a lot you can do with something like this. You could spend a lot of time experimenting and seeing how well this amplifier works, how to modify it, how to improve it. But it's again one of these topics in electronics that you could spend a lot of time on something like this, and I would say this kit, out of the ones I've shown so far, is probably one of the most interesting. It's certainly one of the most fun ones to build. I think it could be extremely informative in terms of learning electronics. You've got a whole mix here of a small signal, a high power output. You've even got a power supply that you could play with to further improve things. So I think at £6.50 it was well worth the money I paid for it.